Why I
to split you up already. In section 2.1, there's just a few quick definitions to go over, and I'm sure you remember a lot of it. So I just want to just revisit real fast. Do you remember domain and range?
Yeah, kind of.
All right, what's domain and range?
I remember the, like the name.
Domain is like sort of like a kingdom, except one step higher.
No. All right. Domain and range deals with your x and y values. And when I was a student, they talked about domain and range. I always forgot what was what. So here's the easy way to remember domain and range. What comes first in the alphabet, x or y?
X.
X. What comes first in the alphabet, domain or range?
Domain.
What do you think the domain goes with?
X.
What do you think the range goes with?
Y.
Boy, that was tough.
That's
That's it. Your domain is always going to be your x values. And we get a little bit more involved with this later. And then your range is your y values. I just wanted to just kind of bring back in the definition here without going into too much grand detail about it. It's not as important right off the bat. As we get further along, we start talking a little bit more and more about the domains and the ranges of specific values. You'll see where that comes in. But just wanted to remind you guys, domain goes with the x values, range goes with the y, and the easiest way to remember that is because of the alphabet. Okay. The other part that I wanted to remind you guys of is what's called a function. A function in algebra is going to be any equation or whatnot that for every x value, it spits out only one y value. Let me explain this a little bit better. If I look at a graph, for every x value, all these values of x going left and right, there's only one value of y that corresponds to it. There's only one ordered pair for each x. It's like -4 and 2, -6 and -6, or whatever it may be. It doesn't share y values. There aren't any different y values. In other words, it can pass what's called, you might have seen this, a vertical line test. You ever heard about that?
No.
Anytime you have a graph, you can take what's a vertical line, and if that vertical line goes across the graph, and it only touches the graph in one spot, it's a function. Because if it didn't, it wouldn't be a function. So what happens here, a function, for every x, there is only one y value. In order for a function to occur, for every x, there's only one y value. On a graph, that means it passes that vertical line test. Yes, sir?
So the only way a function wouldn't work if we had a horizontal line or a vertical line?
Horizontal lines are functions. Vertical lines are not.
Okay.
All right. Horizontal lines are functions because
They go, yeah.
it'll pass that vertical line test. But if I have a vertical line, all of a sudden I'm touching it in more than one spot. I'm touching it in infinite spots, therefore it's not a function. Okay. And we get in more, we actually work with non-function stuff later on. We're going to graph hyperbolas and all this kind of crazy stuff later. But for now, I just want to show you this. You might see it from time to time, just a quick graph, and it might ask you, is this a function? It might look like this. Oops. Is that going to be a function?
No.
It's not going to be a function. Is a is a circle a function? No. Okay. It's not going to be a function because it touches more than one spot. You'll see stuff like that. I just want to kind of briefly describe and show you a couple things about functions. We do a lot of what's called function notation. We get involved with more function notation in 2.7, which will be next Tuesday, when we start to deal with what are called piecewise functions. And each graph has a little chunk of it. So that's really all there was in 2.1. Like I said, it only was going to take me a couple minutes to go through it. I'm not even getting any homework out of it. I just wanted to remind you guys of what that stuff looked like. Now, 2.4. What I like to call quick graphs. 2.3. What I like to call quick graphs. Yeah, you know, reading is not my forte. They still have Cliff Notes?
Yeah.
That's what I read, kind of. One thing you'll notice if you're not the world's greatest, or you don't like to read as much as other people, it doesn't. If you're in class and your class has really good discussions, and they talk about specific quotes and specific things that are in the book on specific page numbers, really, really good notes. Use those in your papers. Oh, I just recorded that too. Anyway, quick graphing. So, for example, we've all been graphing equations for a long time in plain old boring slope-intercept form, right? Y equals mx plus b. Oops. That's again.
Oh.
Or this is even better, right?
Oh.
You guys didn't know these things bounce?
No.
I do that.
Yeah, I feel sorry for
That was smart board.
You can make a smart board out of a Wii controller and a like a flat screen.
No, I don't want to do that. I want this.
Oh, they're only a couple grand.
Sounds legit.
There's just a smartboard app out there that does like all these things.
You can, I mean, there are a few apps that you can mirror desktops, and I had one on a tablet. It just didn't work right. It was the lag was too much. Anyway, so when we would graph stuff in slope-intercept form, it's a very standard way you guys all learned. It was beaten over your head to do it that way, where whenever you have a graph, and I'm not going to get too crazy involved on this, but oops, let's say it was, oops, just move this out of the way for now. Y equals 2x minus 3. Where would you start that? Where on minus 3? X-intercept, Y-intercept?
Y-intercept.
And then what would you do?
Go up 2.
Up 2 over 1? Okay. So this is what you guys are accustomed to doing when you're graphing. You put things in the slope-intercept form, you plot at the Y-intercept and go. That's what you guys have been taught and trained to do over and over and over and over again. What if I told you there is a much, much, much simpler way?
So you're lying.
I'm not lying, and you guys are going to get mad at me because you weren't shown this years ago. I found out last hour that there were a couple of students that have seen this, but not that many. Do we all remember what this is?
Standard.
That's what was that? Was like where equals b.
There's a b in there, yeah. It's the ax plus by equals c.
Oh yeah.
And they had certain parameters when you had a, b, and c. A was always positive. A and B both not equal to 0. The reason why they both can't equal 0 is because if A and B were both equal to 0, you'd have 0 on one side of the equation, then C on the other side, so you won't have a linear equation at all. If A was 0, that means you have y equals some number, and if B was 0, then you would have x equals a number. That's how you're able to get your x or y intercepts eventually here. And the other thing with the standard form is that you had to have a GCF of 1. Remember, the GCF of 1, we're talking like your A, B, and C values. If it was like 6, 12, and 18, you can divide them all by 6. That kind of stuff. All right. From what I understand, you guys work a lot with this. They always force you to rewrite things into standard form and do stuff, and then take things out of standard form into slope-intercept form before you graph them. You worked a lot with what are called literal equations by moving stuff around. When you were first taught how to do that, it was just an exercise in moving and solving for independent variables. Now I'm going to show you something that makes life really, really easy. And it stems from intercepts. If you have a graph, and you guys don't have to have fancy graph paper or anything for this right now, and I have an x-intercept at 4. What's the value for y? 0. What's the value for y at every single x-intercept? 0. Then what's the value of x at every y-intercept? 0. So for every, at the x-intercept, y equals 0. And then at the y-intercept, x equals 0. You with me on that?
Yeah.
So if I take an equation that's written in standard form and I want to graph it, I'm going to graph it via the intercepts. Here's how I do that. I'm going to take an equation. I'm just going to erase these real quick and leave this up. I'll say it's 2x plus 3y is 12. It's written in standard form. A and B are both not 0. A is positive, and the GCF is 1. It all works, right? If I want to find out what the x-intercept is, that means that y equals 0. What's your x-intercept? Solve for x. 6. All right, so your x-intercept is 6. What's your y-intercept?
4.
Connect the dots. Done.
We've done that.
That's it. That's how you graph things quickly. You use your x and your y intercepts. You cover up the x value to get your y intercept. You cover up the y value to get your x intercept. Connect the dots. La 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 la. You ever seen that?
Yeah.
Couple? Okay.
Absolutely.
So last hour there were out of the last hour's got a lot more people. There's 32 in there. You know, I think like 6 people have seen it. Everybody else might have been still sleeping, but it wasn't that many. So what's nice is that you're able to, instead of having to get everything in slope-intercept form, you can just cover and solve. And obviously that one. Another example, and I'm not going to even bother with graph paper today. We're gonna do things just kind of rough sketches. It's still there. It's there. Right there.
Oh, it's like Whoville.
I don't know that reference. Is that exactly?
Christmas? Or no, wait, a second. That's what I meant, but actually Whoville can also be on a snowflake, so technically.
Oh, that's right.
No, it was like, was it getting dust?
It was on the flower.
Wasn't it like-
thing.
It was on
Yes,
spec.
it was on the little.
I think it was
Are you ruining it for me?
It was a little speck on the dandelion.
Right.
That's Inville, and that's sitting
You
with
can't exactly-
Ward.
Oh,
It's-
okay.
No, that's
And then like, we got thrown into that patch of flowers.
But, hey, so I don't need to go buy the books for my kids now? Thanks.
Okay, yeah.
No, by the
That's good.
movies.
That's a good point.
It's
Digital now.
All right, anyway, same idea here. Is it okay that the y value, the b value is negative? Yeah, there's no rule that says b value can't be negative. It's perfectly fine if b value is negative. So I do the same thing. I just make a quick little xy grid. X-intercept at 2. Y-intercept at? I try.
Yeah.
Now, the reason why we show you guys these quick graphs now,
Sorry, I had my ear, so I was kind of.
I thought you were trying to look at it sideways there. One of the reasons why we show you guys these quick graphs now is that as we start building more and more into where we start getting a lot more complex, in about a week and a half from now, we're going to start a section, maybe 2 weeks from now, we're going to start a section called linear programming. And in that section, we not only use quick graphs with equality, We also throw inequalities on there, and we do some shading. So what you're going to be doing is that you're going to be able to create these shaded region to find maximum, minimum areas, intersection points, all by the use of these very quick graphing. That's why we show you guys this stuff now to get you ready for it. Okay. The only other real part that I had for today was what I wanted to go back and just kind of remind you guys about horizontal and vertical lines, what the differences are in their graphs. Because, once again, every single horizontal line always has the same start of a graph. It's always, always, always y equals some number. It will always be y equals some number. Positive, negative, fraction, decimal, doesn't matter. You all right?
Yeah.
Okay. And then by process of elimination, what do you think every single vertical line is going to look like? There's always one. X equals some number. Okay. That's one of those things to remember. They do show up often, as you can see from the earlier from yesterday. We weren't quite talking about horizontal vertical lines right off the bat, but they were talking about horizontal and vertical via perpendicular and whatnot.
7:32.
I think there's really not that much more in this stuff. I mean, we could graph these all day long if you want.
No, I don't. Just do it.
How would you graph this?
Green.
Good. Now let's do this, because there's really no need for me to go through and find slopes and intercepts and stuff and all this extra graphing. I'm going to give you some homework. You've got 15 minutes. You'll get this done.
Oh, that's right. Oh, here it is.
On section 2.3, page 87. We're at 7:51. Just quick graphs here today, ladies and gentlemen. Just
43.
that's it. That's it.
Okay.
Draft.
Yep.